So we're going to end off with Jamie, who leads the group, but who also will bridge this gap, the COVID TB gap, from a vaccine perspective.
Thank you. Okay, so I guess for those of us coming relatively late to the COVID vaccine party, we always get this question. And I think when we were probably asked this question at the end of last year in December, when the mRNA vaccine results had come out and we were seeing a decline in cases globally, you know, you could have said, well, maybe this is valid, but I think as we're now where we are at the moment, and we're confronted, I think, with the end of last year, where we've now had these are global deaths up until mid-May, when we can see we've got these waves, and so it's globally, of course, we're in still a pretty tragic situation. We have evidence of reduced efficacy for some of the vaccines against some of the new variants that are circulating. We have issues with vaccine hesitancy, and we also have the issue of ensuring that we can distribute vaccines globally on a level playing field, and getting them to the areas where they're needed, and that may require vaccines that are more cost effective and easy to transport, etc. So we think there's a lot to do in this space, and now I guess as Australians we could probably think that someone described our vaccine as the Bradbury vaccine. So while some of the others, hopefully most of you understand this reference, why some of the other vaccines might be falling, the Australian vaccine might come in at the last minute and take the gold medal. So that's where we're heading, hopefully. And so this is just to highlight this differential we see for some of the variants. So we're quite interested in variant vaccines, which I'll show towards the end. So certainly we can see that, and you know, it is remarkable that we have a number of vaccines that are highly, highly effective, and these were generated in a short time frame. But we do see differences in the capacity of our current vaccines to protect against, in particular, this 351 or South African variant, which is probably the most problematic in terms of immune escape. And this is really related to, the capacity of vaccines to induce neutralizing antibodies that neutralize these variants. And I'll talk about this in a minute, but this is just showing that you see a reduction, but I'll go into this in more detail. That'll be a bit clearer. And the other thing I saw this morning on Twitter, and I thought it was such an impressive graph, is that I guess even in areas where vaccination coverage is quite good, so this is in the UK, and we're looking at different regions of the United Kingdom, the grey is the 117, or the old UK variant, which I think is still globally dominant. And then what we can see is the emergence of the 617, which is one of the so-called Indian variants, which is now becoming, I think, most dominant in the UK as well. So I guess the issue of these variants is certainly still with us. So now we're in a TB-CRE, and I guess the reason I'm here is because I have a long interest in tuberculosis and BCG and vaccination. So we've addressed this question, and when I say we, in fact, it's mainly Claudio. Claudio's done all of this work. I'm a little bit like the Andrew Ridgeley in this relationship. Again, if anybody knows that analogy, Claudio doesn't, so that's good. What we've been doing is looking at can we use BCG in a capacity to improve vaccination against COVID-19? And so, of course, there's a lot of interest in the off-target effects of BCG, and there's a lot of evidence that we do have these non-specific effects of BCG that can be beneficial against other respiratory infections and other viral infections. And we know that at the moment there's a large clinical trial going on, which is an international clinical trial headed by Nigel Curtis at the MCRI in Melbourne, who's looking at the impact of BCG vaccination in healthcare workers against COVID-19. And that's really, again, looking to see, can BCG alone, considering it is a non-specific vaccine for COVID-19, induce a level of protective immunity? And in fact, one of the first things that I say we, but actually Claudio did this, was to look at this in a concept of what happens if you have mice that you've previously vaccinated with BCG and you've left them in the animal house for a while, and then you convince everybody you've designed this experiment specifically to look at the impact of a COVID vaccine. And so what we did was to vaccinate these mice with a combination of the spike antigen, so the major antigen that's present in all the vaccines, and this is from the original SARS-CoV-2 variant, together with a globally accessible and well-known and safe adjuvant, which is alum, and then look to see what happens to the spike-specific antibody response. And in fact, what we notice, so this is looking over time, what we notice is that if these mice have previously been given BCG, they have a somewhat greater generation of anti-spike antibodies. So what it's indicating is that non-specific capacity of BCG to activate the immune system has helped generate a specific response against the key SARS-CoV-2 antigen. So we think that's nice evidence that there's something here to pursue. So this is what we did. And in fact, so this is a vaccine. So this is one of our vaccine candidates, which we call BCG CoVac. And so what we've done is we've said, well, what happens if we just do this all at once? So if we make a single vaccine formulation, we take the BCG vaccine, we combine it with spike protein, and then we also look at the impact of adding in additional adjuvants to potentiate that response. And so we've been quite fortunate. We've been working with a company in Switzerland, which is called Exelgene, and they're very good at making recombinant trimeric immunogenic spike proteins very quickly. And so we're working with them in terms of having access to these proteins. And then we've combined it with BCG. We know what that does, and alum. And the outcome was pretty good. So what Claudia was able to show here is that what was very clear early on is when you immunise these animals and you looked over time, and I've simplified this in terms of the groups, and this is looking at the level of neutralising antibodies. And I think it's pretty well established that these are important for protection against SARS-CoV-2. So this is the level of neutralising antibodies. So these are antibodies that can block the capacity of the virus to enter cells via the ACE2 receptor. And what you can note here is that our BCG CoVac, so that's essentially alum and spike, a more prototype vaccine, where we've added in BCG, we generate the greatest response. So we get about a 1 log increase in neutralising antibodies when you add in the BCG compared to not having BCG. So again, we've been able to show, I guess, in a functional sense that BCG can improve your capacity to make this response. And if you compare this to individuals who have been previously infected with SARS-CoV-2, so this is not from mice, this is from actual humans who are infected, and you can maybe make a comparison, and this is the level of antibodies that they generate, neutralising antibodies using the same assay. And we can say that at least in this murine system, the level of antibody production is pretty strong. Now, this is just a gratuitous plug to a paper that came out not long ago from our group. But what I think this is clearly showing here, and what we did in this study was to compare, and again, looking at the vaccine trials in people, not in mice, the vaccine trials in people, and the generation of neutralising antibodies. And what we've been able to show is that there's a clear correlation between how well the vaccines generate neutralising antibody responses and the relationship between their protective efficacy. And this also, if you model it, it appears that clearly, and again, you might think this is obvious, but I think making the association was quite important, that those vaccines that generating the strongest responses are clearly the most effective and probably will maintain their antibodies better over time. So neutralising antibodies for us is the key correlate of protective immunity, and that's what your vaccines should do, and they should be inducing them to as high a level as possible. So the other thing that Claudia looked at was looking at the T-cell response. Now, I just showed you that we think that neutralising antibodies are everything, but I think it's also important the type of T-cell immunity you generate. And historically, we've thought for coronaviruses, generating Th2 immunity is a bad thing because in animal models of the original SARS, it was shown to be detrimental. And driving Th1 immunity is what you want to keep your vaccine safe and effective. And that's what we've been able to show. And this is clearly due to BCG. So we know BCG is fantastic at inducing Th1 immunity. And what Claudia has been able to show here is that in, keep pressing the wrong thing, in these animals, looking at the number of T cells that are making interferon gamma, it's only in this BCG CoVac vaccine where you see very high numbers. So it's pointing the immune response in the right direction. Now, I guess the thing that we were really excited about was the capacity, together with the Hansborough lab and Bernadette, who's here, and also Warwick, who have established a model of SARS-CoV-2 infection in mice. So these are mice that are expressing the human ACE2 receptor, because mice are not naturally susceptible to SARS-CoV-2. And so what we've done here is we've looked at the capacity of vaccination with either BCG alone or our vaccine. Do they protect mice against infection? And what's the level of protection that they that you see on the basis that in a lot of the other experiments you can get reduction in numbers in the airways and in the lung, but it's not always clearing that infection. And so the outcome was, I think for us, was pretty fantastic. So here, for example, we're looking at body weight. So this is how well these animals do over time. And we can see in the maroon red, what we notice is that these animals are quite happy. They maintain their body weight throughout the course of the disease after they've been infected. If you give them BCG, in fact, you can see there's a bit of a partial effect. So there is some protection against at least reduction in body weight. And if you don't vaccinate them at all, they start to lose their weight quite quickly. If you then look at the, this is the clinical score. So this is just observing these animals and how happy they are between, and this is not very discriminatory, but what you note is that animals that were given this vaccine were very happy, no clinical signs of disease. If they were not vaccinated or given BCG, they did show some signs. But what we were really excited about, well, I guess it depends what you're looking at. If you're really interested in BCG, you might say, well, in this scenario, we're looking at the capacity of these animals to be protected against infection. And so here we're looking at the amount of virus that's in their lung or in the bronchial lavage fluid. And what we notice with this vaccine, we get complete clearance. So there's no virus at all in these animals. You can see with BCG is you still see virus. So I guess that's interesting that it appears that you get some protection against severity, at least in terms of body weight, but this is not represented in the amount of virus that's present. The other thing I won't show, in fact, is that you also see this intermediate effect in the level of inflammatory cytokines as well. So it appears that maybe BCG is reducing the inflammation, but not necessarily having a major effect on the viral load. And hopefully of interest to this audience, what we were also able to prove or confirm was that this vaccine can still protect against tuberculosis in mice. So we haven't compromised the capacity of BCG to protect against TB. It's this vaccine or BCG itself is very similar. So just a few more slides. I've probably gone over time, but
Maybe another minute.
yep. Okay. Yeah, I don't need. Oh, it's your mistake. Okay, I'll go back. So the other thing that we had shown, so working with Stuart Turville at the Kirby Institute, and he has this amazing setup. I think every variant that's come into, well, I shouldn't say that. He's got a lot of variants that are from around the world. So Stuart has set up this capacity to look at the development of neutralizing antibodies against the different variants. And what we were able to show, and I think quite nicely, is that mice given BCG CoVac, and we've actually given them a boost with another vaccine, but I can talk about that later if you want, with spike alum, you can still generate neutralizing antibodies or a neutralizing antibody response against these variants. So if you start with a high level of antibodies, you can neutralize the UK and the South African variant, which is encouraging. And just for the last couple of slides, I mentioned we were working with Exel Gene, and we've been quite interested, we can talk about this maybe later, about the application of a BCG-based vaccine. So we've also been looking at approaches we could use that don't necessarily include BCG. For example, if you want to generate a boosting vaccine to give to people who are already vaccinated. And so the way we've done this is we've looked at combinations of spike protein with new generation adjuvants. And one of the adjuvants we've been using is from a company called ViraVax, and their adjuvant is called allodroxyquim. And this is the adjuvant that's in the Covaxin vaccine. So Covaxin is an inactivated whole virus just being used in India. So it's Bharat Biotech is the Indian company. And this is a really amazing adjuvant. So it's been shown in people, but also in mice, in our system, that if you combine the spike protein with this allodroxyquim, we call this CoVac 2, with a single dose, you see so these are neutralizing antibodies over time, very strong amount of neutralizing antibodies. It's better than BCG CoVac. And if you boost, so if you give 2 doses, you get a fantastically high response. So you're generating really strong levels of neutralizing antibodies. And this also maintains some level of protection against the variants. The other thing that we have just done now is Claudio has just set up this experiment, and it's very, very early days, but what we have now done is so the advantage of this system, I guess we talk about mRNA vaccines, but these guys can turn around or churn out recombinant proteins pretty quickly. So we now have access to spike protein from the 351 variant and the 117 UK variant. And what we've shown in a very early experiment, in fact, we've only given 1 dose, and the next dose was just given, I think, Claudio? Well, yeah. Is that if you immunise mice with the adjuvant, so this is the spike protein here is the original Wuhan protein, or you immunise mice with the 351 protein, so the spike protein from the variant, you generate a stronger immune response when you look at neutralising antibodies against that variant. So it's showing that we can generate strong variant-specific immunity in this model. So just to finish up, I'll go through this quickly, Ben, but yes, I think we've shown BCG has this adjuvant effect, and I guess the issue is here, is there utility? Is this for a standalone vaccine, or is this a way that we could develop potentially a pathway of combining BCG with currently approved vaccines, for example? We're moving forward quite quickly with this CoVac 351 vaccine. So we have funding now to assess efficacy in a second animal model, which is hamsters, and this is now set up. We're looking at safety in immunogenicity and safety in a pig model. We're doing toxicity studies, and we're preparing for a local phase 1, pending funding. So there's a lot of people to thank. Claudio, who's really driven all of this work, and we've got other members of the lab, of the school that are involved. Megan, for example, who's helped us set up the pseudovirus assays for measuring neutralisation. The team at UTS Centenary Centre for Information, Phil Hansbrough and all the others involved there has been fantastic. Warwick, as I've mentioned, Exel Gene, Stuart Turville's team at the Kirby, Sunil David at ViraVax, funding through the MRFF. And I'll also mention that we have received, Megan and myself have received seed funding through the CRE and the University Drug Development Initiative to develop some of these screening platforms. So I will stop there. Thank you.